Okay, the second one here. The third question. The following table presents in summarize that the incomplete, the informed relevant to this one, three gases testing things. Okay, so in your syllabus, we are discussing the three gases, the carbon dioxide, hydrogen, and oxygen. First one is, it gives the glowing splint lighted is the gas here. The glowing splinter is lighting with the oxygen gas. So we can get this one as the oxygen here. And the holding the glowing splint and the oxygen is here. And this is the water and the when we getting this one, the adding blank dropwise on manganese dioxide solid. The manganese dioxide and it is getting the hydrogen peroxide, H2O2, hydrogen peroxide and dropwise on the manganese dioxide solid. And it is forming the water and the what is the substance left in the reactants mixture after the reaction. Remaining is the water and manganese dioxide. Right? The gas is releasing, no? Oxygen gas releasing and water and the manganese dioxide is releasing. If you consider about this hydrogen peroxide, you know hydrogen peroxide H2O2 producing the water and oxygen. Right? This manganese dioxide is acting as the catalyst. That means at the end of the reaction, the manganese dioxide is remaining without converting it into another substance. Hydrogen is releasing. That hydrogen we are identification is the holding the lighted alkyl. Then the what is happening? The gas is burns with pop sound. It's a pop sound is there. Gas is burns with the pop sound. Then it's forming the zinc chloride, right? The zinc chloride is producing zinc chloride. Uta, to produce the zinc chloride, the metal should be the zinc. The metal should be the, now here it is produced as zinc chloride plus hydrogen gas, no? Then the metal should be the zinc. And hydrogen and chlorine mean the acid is the HCl. Adding the dilute HCl on zinc metal. The last one, the carbon dioxide. Carbon dioxide, we are using the colorless lime water, right? We are passing the gas through the colorless lime water. Then what is happening? The lime water, the observation, the lime water turns into milky color. Please write your words, Pute. That the identification of these gases is really important. To identify the oxygen hold in the glowing splinter and the splint is lighted. Hydrogen entering the lighted alkyl here with the flame you need adding. Then the gas burns with pop sound. And the carbon dioxide, we should that some people are just using that after entering the ignition thing that the fire extinguishing nature is there, no, the carbon dioxide, but that is not the method of identification of the carbon dioxide. To identify the carbon dioxide, we need pass the gas through the lime water. Color of the lime water is colorless After pass the gas through the lime water, it turns into the milky color. Remember that one. And here the magnesium sulfate and the water is producing. Magnesium sulfate, water, and the carbon dioxide. It is getting the carbon dioxide as well. No? So what may be the thing? Here the dilute sulfuric acid is there, H2SO4 there. To sulfuric acid, what type of thing we need put? Right? Here the magnesium magnesium sulfate is there, right? Magnesium sulfate and the thing, no? So it's better to magnesium carbonate, right? The magnesium carbonate and the sulfuric acid should be there. In your textbook, the method of the producing the carbon dioxide is the calcium carbonate. When using the calcium carbonate and the acid, we are getting the calcium containing thing. Now here, keep that in your mind. The product is the magnesium carbonate. If the product is containing the magnesium, the carbonate we are using should be contain the magnesium, right? So after seeing in the product, you should have ability to find the reactants, right? From the reactants, you should know how we can get the product. And the other hand, if they already given the product, you should ability to get the reactants as well. And the B part. Now that in this question, they given the real elements. If keep that in your mind, if they didn't given the real elements, then you need go with the symbols. Now, if they given the symbols, when answering, you should use the symbols. But here they already give the real elements, so you can go with the real elements. Fill in the blanks in the following sentences using the elements given in the table. Element with the maximum first ionization energy is, right? First ionization energy maximum is, you know, the 8 group one. Out there here that the 3 8 group elements are there. Out of that one, the helium having the highest, the maximum first ionization energy. Once again, first ionization energy mean that release one electron and forming the positive gas state ion. And the first ionization energy is maximum in the 8 group elements. Now here the 3 8 group elements given there, hydrogen, neon and argon. Out of these 3, the helium having the maximum first ionization energy. Second one is the element of the highest electronegativity. 7th group elements having the highest electronegativity. Out of the fluorine and chlorine, the fluorine having the highest electronegativity. Electronic configuration of the magnesium. Magnesium belongs to the third group, third period, and the second group. So it is the 2, second energy level 8, and the third energy level 2. So the 282. Formula of the compound formed by the combination of the aluminium and oxygen. Aluminium and oxygen. First you need get that the valency number of the aluminium and oxygen. Aluminium belongs to the third group. So the valency number of the aluminium is 3. And the oxygen, it's the 4, 5, 6 here. So the oxygen, the valency is, here the oxygen belongs to the 6th group, mean valency is 2. Right? So we can write these ones are the valencies. The valency of the aluminium 3 and the oxygen is 2. To get the formula, we need exchange these two. So we are getting the Al2O3. So the aluminium oxide we can write as the Al2O3. Then the second one, in the following sentences, select the appropriate word out of the words given within the thing. the bond of the compound formed between the hydrogen and chlorine is covalent. That the bond forming between any one, that the hydrogen always forming the covalent bonds. Hydrogen always forming the covalent bond. Remember that one. Oxide formed by the combination of aluminium and hydrogen is aluminium oxides are there. No? We learn the aluminium oxide is the very special one. It is the amorphous. Normally the metal oxides are basic and the non-metal oxides are acidic. But the aluminium oxide is a special one. It is the amorphous. It is neither acidic nor the basic. So that is the thing. So that is the end of the third question. And please answer the fourth question. Answer the fourth question. Now the fourth one, it is grade 11, the ray diagram parts one. No? In an activity related to the light, the student placed the glass block on the white paper, and here the A, B, C, D places are there. First one, by what name is the phenomena known as with the ray is subject after falling on the point B? This one. Now this is the glass block and the light is entering from air medium to glass medium. They both are the transparent medium. When the light is entering from one medium to another medium, it is bending. This one we call as the refraction. Refraction. What is the reason for the refraction? Right? This is the refraction. This is the answer. In the exam, if asked that what is the reason for the refraction? Reason is the speed of the light in the different mediums are different, right? So the speed of the light in the air medium and the glass medium, they are different. Because of that, when the light is entering from one medium to another medium, the bending, right? It is now here you can see it's bending. Keep that way in your mind that the two mediums are there. That the medium having the high speed of the light we call as the rare medium, and the medium where the light speed is less we call as the denser medium. So in this one, the glass is having the denser medium and the air is having the rare medium. Always the rare medium, the angle is bigger than the denser medium angle. Remember those points. And the angle A is the angle of incident. Here this is the incident ray and this is the refracted ray. This is what we call as the incidence ray. And this is we can say as the refracted refractory, and the angle between the incident ray and the normal we call as the incident. We call this one as the angle of incidence angle or angle of incidence. And the angle B is the angle of refraction. Third one, when the value of the angle A is increasing, when we are increasing this one, how does the value of the angle B change corresponding to that one? We can write when the A is increasing, B also increases. Right? When we are increasing the A, the B also increasing. According to the figure, what is the phenomena that the ray is subjected to the point C? Now here that the light ray is entering from the glass medium to air medium. So the normally it should goes to, it should enter from the glass to the air medium. But in this point, without entering or without refracting, it is bouncing back. So the bouncing back, this rays we call as the total internal reflection. Total internal reflection. Okay. And the fifth one, that if the angle, state the device that adapt to the phenomena you mentioned in the 4 total internal reflection about the modern communication technology, right? That is the optic fibers. This one we are using in the optic fibers. The angle between the BC and the normal x is the angle x equal to the greater than or smaller than the critical angle. Now if it is equal to the critical angle, right? If it is equal to the critical angle, I think you can remember it is moving like this way, right? And if the one is less than the critical angle, I'm talking about this angle. If it is less than the C, then it is entering to the second medium. So if the angle is greater than C, then only the total internal reflection is happening. Now the question is asking, so what will happen to this type of thing? It is the greater than here. So the x is, we can write the x is the greater than the critical angle. Critical angle. And the B, colored water there, the color water drops moves up and air. We are heating and this is happening. So this is after we heating, that what is observation. So the setup A is formed using for the thermal expansion of the liquid. Here we are using the water. So if you can write that the thermal expansion of a liquid, or you can write a water as well. And the B setup here inside it is having the air. So this is explaining the thermal expansion of a gas, right? Thermal expansion of a gas or air. And the second one, when they heated for some time, what changes can be seen in the narrow glass tube in the above 2 setups. Now, this one you can see the water level rising up, and the second one, here the colored water drop is rising up, right? So here the water level moving up, and here the colored water drop is moving up. And the third one, by what method is heat transferred across the wall of the boiling tube in the setup B? The heat is conducting in the 3 methods: conduction, convection, and the radiation, right? So the heat transferred across the wall can happen in the the conduction we can get, but the conduction better in the solid form. This is a glass. Here also we can write the conduction, and the other than the conduction, it can be go with the radiation as well, but not the convection. And the last one, the mass of the water in the boiling tube, here the 50 grams, right? M is the 50 grams, mean to convert that one into the kilograms, you need divide that one by 1000. Initial temperature of the water is 30 Celsius. If the mass of the water got heated up to the 40 degree, calculate the quantity of heat absorbed by water. Then you can use the equation Q equal mc theta equation. The mass is the 50, need divide that one by 1000. Specific heat capacity 4200. And here the temperature difference is 30 to 40. That means the 10 Celsius there. So the 2 zeros, 1 0 we can cut, and the 0, 5 times 2, 10, 1 is remaining, and it's 2100 joules are there, right? Q equal mc theta, m for the mass, you need convert that one into the kilogram, don't forget it, and the C for the specific heat capacity, and the theta for the temperature difference. Here the final temperature is 40 Celsius, initial temperature is 30, then the theta we can calculate by 40 minus 30. Now normally we need convert that now, because it's a unit for measuring the temperature is the Kelvin, right? So this is unit is the Celsius, so we can use the Celsius. Other than that one, if you convert that one into the Kelvin and get the difference, the same answer we are getting, right? So when you are getting the difference here, both the Kelvin and the Celsius, we are getting the same answer. So the temperature difference is 10. So they just ask about the heat absorbed by the water, so we can get the this type of calculation. But if the question is asking like that way, like the water in a equipment or something, that the water in a vessel, in that type of question, we need calculate the heat absorbed by the water and heat absorbed by the vessel, and we need to get the total heat, we need add that two together. But in this case they ask only to calculate the heat absorbed by the water, so you can get the answer as this method, right? So keep that in your mind, the structured paper, when you answer the structured paper, even the marking scheme, that the direct answers we are getting, right? So that the specific space given there, that the specific answer is there, you should write that answer only, right? There's a scientific names are there, scientific words are there, you should use that words. So that is the end of the structured paper. Okay, let's move to the B part of the second paper.